I just want to say a quick thank you to the Web Rebels people because I'm about 7.5 months pregnant, and when they asked me to speak, I said, that's great, but I live in London and I don't want to accidentally give birth in Norway without my husband. And they said, that's fine, you can bring him. And so he's actually here today. And so thank you for inviting me to speak, but also thank you for making it possible for me to say yes to come and speak, because it meant a lot, so it's good. And I also, I saw another pregnant lady in the audience. I thought I'd be the only one, but solidarity, sister. I feel your pain. So let's have a go. So I'm going to be talking about leap motion and VR, so motion sensing. My name's Mairead. I'm a developer. I've been working as a developer for about 15 years, and I specialise in front-end development because the bit that I really love is interactions and making stuff happen with JavaScript. And that's kind of how I fell into using 3D motion stuff, because I found out that you could plug it into a browser and you could use JavaScript. And, I wanted to see what I could do if I plugged that into the internet. So I've just got a little bit of a narrative about what I'm talking about today. I'm going to introduce a project that I'm working on. I'm going to talk a little bit about how you use 3D in the browser, although David's covered some of what I'm going to talk about, so hopefully that's not new to you. A little bit about some of the mathematical language that you need to get your head around if you're using 3D stuff. And then I'm going to talk about the input device I'm using and the output device I'm using to do 3D, and some of my web architecture for the JavaScript application, and then a bit about kind of getting a virtual reality effect into the output device, and then what my intentions are for the future. So I'm just going to start off with a bit about the project I'm working on. I started on this years ago, about 4 years ago. Somebody wrote a hack for the Connect device, and I think that that's what is playing downstairs. Someone's got libfreenect running, and I started mucking around with this because the team at MIT had built a JavaScript library, and I thought, brilliant, that's something that I can do. But I was a bit frustrated at the time because the device couldn't really do near field and it couldn't do finger detection. So I switched over to a Leap device when it came out, and actually it's a bit nicer to work with, because if you're not a C developer, getting libfreenect to run on a Mac is gross. And then last year I was kind of experimenting with building a moving hand with the finger detection, based on a couple of articles that I'd found, and doing my own Blender 3D models. And then recently I kind of came across the Google Cardboard device that someone was demoing at a London front-end meetup. And that's it's a really kind of natural partner for the project I'm working on, so that's what I'm showing today. I heard someone earlier, some of my slides don't quite fit on the resolution. Real-world applications for this technology, I heard David say earlier, why would you want Oculus in a browser? Why wouldn't you? There's all kinds of stuff that you can do with this technology. And I would say, even though I've been working on it for quite a few years, it's still quite early days for these things. And I think that people quite often come up to me afterwards and say, yeah, but what's it for? Or how do I use it? Or I bought a Leap and I don't know what to do with it. So there's a couple of kind of specific use cases, but you need to solve a problem that you have. It's got quite a natural partner in 3D modeling, because at the moment, if you make 3D models, you have to do it in a 2D interface, and that's quite cumbersome. So anything that involves product design and CAD 3D modeling would be really useful to have a 3D interface. It also has kind of a natural partner in anything that involves movement, so rehabilitation and health, where you're kind of tracking a human body, and also kind of sports tracking and that kind of data monitoring. 3D kind of input's really useful for that kind of thing. If you've got kind of 3D wearables that can track you without needing a camera, then that's really good for sports people to wear. But the best thing that I've found so far, or the most exciting for me, is this demo. There's a link here. I didn't want to show his work because it's his, and I think you should go and look at it. But he... forget Minority Report. This guy's, I don't know if you've seen Iron Man, I'm assuming you have. He's got this really beautiful kind of 3D computer that he can move with his hands. Robbie Tilton's actually come quite a long way to recreating that. He's got projectors and kind of glass mirrors. So he's actually projecting a hologram, and then he's using all the rest of the technology I'm going to show you today, which is Three.Js and WebGL and the Leap, to move that with his hands. So he's like, that's straight out of Hollywood, but he's actually come quite close to making something in the real world. So that's quite exciting, I think. So what I'm going to be talking about today is the Leap Motion, which is my input, and a Google Cardboard, which, if you haven't seen one, is here. It really is just a piece of cardboard and a couple of lenses. I'm using a combination of kind of WebSockets and WebRTC because the cardboard takes a mobile device, so you need to be able to communicate from the Leap device, which is USB, into the mobile device, and then also using the accelerometer data from a mobile. And I've just got a little... This is my diagram of my technology stack. You're kind of, what's in the middle is kind of like a 2D layer, right? Because you've got, these are screen technologies because they're browser technologies. So you're taking 3D data and then you're mapping it with kind of Cartesian mapping onto a 2D screen, and then you're projecting it back out using kind of 3D, like a combination of 3D hardware and a screen. But there's kind of like 3 layers of JavaScript going on there in between the device, the input and the output. So David touched on a little bit of this earlier, but in case anyone isn't really familiar with kind of WebGL, it's kind of like an API layer on top of the OpenGL language. So David mentioned earlier, like the shaders, the GL SL shader language is written in a kind of C-like syntax. And what WebGL gives you is a JavaScript API on top of that. So it's partly JavaScript control code, and it's partly C. And you can write your own shaders if you want to, and you can actually write them as strings and then attach them to a JavaScript file as a string of C, which is kind of gross. But you can also write them into a page as a script tag. So you can do that, but you know, unless you really want to, I wouldn't try it because it's horrible to work with. It comes in 2 flavors, like David was saying, vertex shaders and fragment shaders. So vertex maps the edge of your device, and fragment, which is also called a pixel shader, it controls what the pixels of each surface of the device look like. And as he also mentioned as well, because it's written in C, it's like a parallel, so it can compile across every pixel simultaneously. So obviously that's really important because you can't really do that kind of stuff with JavaScript, so you need to have the combination of both of those technologies. And that way it's kind of optimized for the way your GPU wants to work. So, like I was saying, I don't think you'd want to do any of this stuff yourself. Like, don't write your own WebGL, that would be horrible. Instead, you could choose Babylon, which it looks like an excellent product, or what I've been using is this library by a guy called Mr. Doob. And Mr. Doob has been around on the internet since I was a Flash developer, and he wrote all the best, coolest stuff. And he's obviously been working really hard on Three.Js for the last couple of years, and it's a really brilliant API because it simplifies all of the really complex WebGL stuff into like a really easy to learn, easy to read. The documentation's amazing, so it's really simple to get your head around. And it's got all the basic building blocks that you need to do 3D. So you need a camera to look at the scene that you're following. You need geometry, so you need to be able to build shapes and move them around. You need to be able to light a scene, and you need materials. And these 2 things go hand in hand. So a material, like the way your fragment shader works, is determined by the way that light reflects off of a surface. So you can't have a material if you don't have light to reflect off, and you know the lighting is there to kind of light up the way your material behaves. So those 2 things go in tandem. And then there's also loads of kind of math mechanics that he gives you to move stuff around and do rotation and animation. So I'm just going to give you a really quick demo here of the kind of building blocks that Three.Js gives you. So there's a stage and a grid and kind of basic geometry, some materials and lighting and cameras. And so if I had a couple of things here, some shapes, these are just like a non-reflective material. So if you give a material something that has reflective properties, you can see how that is it gives you a different 3D effect, and that changes if you change the lighting on that effect. So Like, that's quite an important concept. And then also, like, you can move it around with the camera. But my favourite, and I don't know why this exists, and maybe David can tell me, because I always ask this question and nobody tells me. This material is called normal, and it's just rainbows, yay! But I don't know what it's for. And like what the normal material is doing is it takes all the colours in the RGB spectrum and it maps it over every vertex that you have, so every flat surface. And my best guess is that it's a really useful way to make sure that your vertexes are all kind of, you can see the colour getting mapped across it. So if you're modelling a complex shape and you really want to be able to see it clearly, then you can give it a normal kind of material and you can see that that's working. But I don't know, maybe it's just rainbows. Everyone likes rainbows. So that's Three.Js. And when I started working with Three.Js, I quickly realised that there was a lot of mathematical terminology in it that I didn't necessarily understand. Or, like, I stopped doing maths when I was secondary school, so at 16, that's 20 years ago, I stopped doing maths. And I was good at it at the time, but I've learned that I've basically forgotten everything that I ever knew. If you work with 3D, then you're working with this kind of concept of Euclidean geometry, which contains the concept of Cartesian space. And, you know, we're quite used to X, Y coordinates, and then you've also got Z, which is, you know, the kind of third dimension. So that's quite useful for describing shape in space. And then also you have this concept of vectors. So a vector is actually just like a three numerical number, but a vector is different to a single point in space. So a single point in space can be X, Y, Z, but a vector is the end point of a line. So if you knew the starting point, which is X, Y, Z, and you know the end point, then you can infer direction, and that's what a vector is. It's about inferring direction. You can see here the black solid arrow. That's the vector kind of moving up in that direction. So that's kind of like, if you're moving things, you either want to translate them from one place to another, or you want to rotate things. So this is my favourite diagram. It's really confusing. When I first came across this on Wikipedia, I was like, whoa, what does that mean? These are Euler angles. And Euler angles are a really simple way to explain rotation in 3D space. So if you follow the large capital Z, which is the blue arrow, to the smaller lowercase z, that black arrow in the middle there, that's the Euler angle of rotation around the z-axis. So rotation makes a lot of sense to kind of like map rotation in angles. You know, the human brain really gets that because you understand rotation. And the green line here is just, it's bisecting a sphere, because when you're dealing with angles in rotation, you actually only need 180 degrees of a circle. So that's one thing to note. But Euler angles have problems. They have like a mathematical problem, and the problem that you get with using Euler angles is gimbal locking. So gimbal locking occurs because you have three kind of angles of rotation. If your first angle moves 90 degrees, like perpendicular to itself, so it's rotating around another angle, and you can see here that the green, if you rotate it, is rotating in the same angle as the blue, then what you get is a near zero value. And when you're using multiple angles, you calculate them kind of on top of each other, and so you can end up with a mathematical failure if you use that. And it's really just a problem with the mathematics. It's not a mechanical thing. So you can solve that by using other forms of mathematical systems. So you can use four-dimensional matrices, and you can use something called quaternions. So Three.Js uses quaternion by default for its rotation to get around this kind of very problem. I just want to give you kind of like an example of that in action and how Euler angles work. So you might have come across pitch roll yaw if you've ever done like an aeronautics simulator, so like flying games and stuff. Pitch roll and yaw, they're also called Tate-Bryan angles, and they're just they're a form of Euler angle. So I've got this kind of trapezoid is mapped to my hand, and it's kind of reading the data from the leap. So if I tilt my hand like in certain directions, I've color-coded it, you can see kind of like moving up and down. I don't know if you can see because I'm not really taller than the podium. If I roll it in one direction, that's roll, and then like tilting it, that should be yaw. But that's the kind of difference in rotation using Euler angles. But so it's just a little bit of kind of mathematical basics. You'll come across that if you're using any of the libraries that I'm going to show you today, then they use a lot of those pieces of terminology quite heavily. So it helps, even if you don't have to do the mathematics yourself because someone else has written that, it helps to be able to read somebody else's code and be like, oh, okay, what is an Euler angle and why is it YZX and not XYZ? Like, that's where it comes from. So the input device I'm using here is a Leap. It's what I'm using to control my slides as well. It's the reason I started using it is because it does finger detection and near field detection. So it's really for kind of close-up work, whereas the original model of the Kinect that I was using was a gaming device, and it was meant to kind of be on the other side of your living room, whereas the Leap is really meant to plug straight into your computer. And it's a lot nicer to work with because it came with its own JavaScript API kind of baked in, whereas I think that the Microsoft Kinect team have probably caught up with that now, but when I was first working on it, they weren't really supporting that kind of stuff. So it's a plug-and-play device. It mimics touch events as well, so if you wanted to use it to control a website, you can, and you can just plug it in and it will act like a touch screen, like it projects a screen into the air you can touch. It's got really low latency. Like the team who built it said that the latency is faster than the human eye. So theoretically, it can detect movement quicker than you can see that detection. And it's really low cost. Like I think they're down to like 60 quid on eBay now. So it's a pretty low cost unit. Like I was saying, JavaScript is kind of like a first-class citizen to them because they wanted something that you can plug straight into a browser. So it comes with its own API and SDK, and it comes with a lot of pre-built objects that are useful if you want to be doing those kind of things. There's a frame, like a repeating loop that you put on the render. It's a controller, so you can tell whether or not it's connected. It's got a couple of objects, which is like a hand, and a pointable is something like a finger coming off of a hand. It's got some gestures built in, so if you wanted to control websites with like a circle and a tap, you can do things like that. But the thing that I think is the most useful, although I'm not sure if you can see it in this slide, it has this thing called an interaction box. So this kind of flattened hemisphere, that's the field of view from the device is actually a circular radius, like a hemisphere. And that's not very useful if you're trying to map it to a two-dimensional screen that's obviously only got X and Y coordinates. It's kind of gross trying to do that math. So the interaction box is actually like a kind of oblong that sits inside of this field of view, and therefore you get a square shape, so you can map the square of your screen to the rectangle of your interaction box, and that makes the maths a lot easier to work with. So that's something that I'm using with this kind of slide display here. So I kind of started doing all of this a couple of years ago, and when I came back to this project, I discovered that they had written loads of really great plugins, and I'd spent quite a lot of, at least a month or so of last year, building my own hand rigging, and when I came back, I discovered that they'd already made their own, and it was loads better than mine, and I didn't know whether to be delighted or gutted because I'd spent ages working on it, but theirs is actually much more sophisticated. They've built in a lot of much better inverse kinematics of how a hand moves and the constraints of a hand bone structure, and it was just a lot more sophisticated. But the downside of using somebody else's kind of third-party code is the same with every other JavaScript library, is you get kind of tied into their way of doing things. So it's golden handcuffs, and it might be loads better than the code that you've written, but I plugged it in and all the rest of my code broke, so I had to go back and rewrite everything. So that's the downside of other people's plugins. So the output device I'm using is this Google Cardboard. When this originally came out, I looked at the website. It was kind of scrolling past in people's Twitter feed, and it was released quite soon after Google Glass, and I assumed that that was a joke. I thought it was a spoof site that Google Cardboard, Google Glass. And it wasn't until I saw someone demoing this in person that I realised that this is actually a really amazing piece of kit, because it is just a piece of cardboard with 2 lenses, and then you put a mobile phone in as the screen. And that is essentially all an Oculus is. An Oculus is using a lot of the same hardware under the hood, but in a slightly shinier plastic case. And this costs £6, and an Oculus costs about 300. So, choose your poison. It's got kind of pros and cons as well. So the cons are you're using a mobile device as your processor, and so obviously that's limited. And in some cases, your mobile device might not necessarily support every API that you wanted. I had some concerns about whether it supported some of the WebGL that I might want, or other of those edge case APIs when you're using a mobile device. That can be a problem. And processing power and battery power. I also noticed it was struggling to charge one day because it was trying to run the WebGL at the same time as I had it plugged into my laptop. So it couldn't charge over USB and do those things at once. One of the other things I would note is if you are going to build your own, it comes in a little kit. It comes with a magnet button. Magnet buttons don't like accelerometers because a lot of mobile devices are using a magnet in their accelerometer for the compass. So you can't put magnets together, so take the magnet off, basically. And then you need to kind of split a stereo screen. So you've got one screen, you want to split it into two views for each eye. I don't know, the thing that I was showing up on the first slides was a ViewMaster, and I don't know if you had them in Norway, but they were ubiquitous in the UK. If you were a kid in the 70s or the 80s, then you definitely had a ViewMaster, and it's literally just two lenses onto like a slideshow. So there's a Three.Js plugin that does the stereo split. So I had a lot of complications with the architecture. I got to the point of knowing that I had my devices and knowing that I needed to get USB data from the Leap, which is plugged into my desktop machine, and I wanted to get that data onto the mobile phone because I knew that I wanted to use it as a 3D view. And the Leap on the USB, there's a native app on your desktop, and it opens a WebSocket that spits data out to your browser. And as far as I can tell, that's locked to your local host, so 127.0.0.1. And the documentation seems to suggest that you can loosen that and that you can port it to 0.0.0, you can put your own IP in. But I couldn't get that to work, and I don't know why that is, and I don't know if that was my home network or what. But so I started trying to do my own workarounds, and I was kind of hacking around trying to get this to work, and there wasn't anyone else really doing it. So this is my first iteration of architecture, which... So I've got a USB device, and it's connected into my computer, and it's talking on port 6437. And then I've got a node server, which opens another socket on 1337, and then that's spitting out data to another node application, which is running a static page, and it's running some client-side JavaScript, and that's connecting. And this is kind of gross because I'm hemorrhaging node servers, and they only take 3 lines to write. But it felt like this was, kind of a bad place. I tried to install the Leap libraries as an NPM so that I could use them on the back end and send data to the front end. But for some reason, the Leap plugin that I'm using to do the hand rigging wants to consume the frame data in a certain way. And when you're piping the raw frame data out of the WebSocket, then they're actually in 2 different module kind of export formats. So this didn't work, but it was starting to feel really gross and horrible. So I kind of backed away from it slowly and went back to the drawing board. And whilst I was trying to Google how to get around these things, because what I really wanted is that I've got a Leap plugin in the client side, and I want to be talking to a device also on the client side, and I need these 2 things to be talking to each other client side, and WebSockets can't really do that because you have to go through a socket server application. But you can do it with WebRTC, and whilst I was kind of Googling around this, I discovered that they'd written another plugin, another team, which is called the Leap Networking plugin. So it's a WebRTC solution, and they're using a third-party service called Three.Js, which is kind of brokering the WebRTC transport. So this is the actual architecture that I'm using here. So the data comes in again on the WebSocket. It's coming into a client-side application, and it opens up a communication channel with the Three.Js service. So it's kind of shuttling messages back and forth. And then I've got another kind of client-side. And I've got these as two separate applications, but they don't have to be. It's just that I kind of had two left over. These could be the same application, and they're just running two separate client-side modules that are talking via Three.Js. And then that way you can connect your mobile device to an IP address and get that kind of client-side frame data into the plugin. So I'm going to show you this working on a separate screen on a browser. Just turn this off for a minute. Let's get this down. So here's this is the Leap network that I want to connect to. So this is the thing that's going to connect to Three.Js. And then here I've got another application that's got my client side, and I've got it split into a stereo screen here you can view. So it spits out an ID, which I'm going to use to connect to my service. And then you can see it connecting. So it says I've got outgoing data, and the other one says, yeah, I've got incoming data. And then, this is actually going client side to client side. So if you wanted to connect another computer up, then you can have two applications connecting over the same network to kind of get the hand rigging data in. So that was kind of like the first step that I took. I was like, okay, so now I know that I can get it running on two screens. So I'm one step closer to getting it to run on a mobile device. And so I before this actually happened, I hadn't found any code anywhere that showed that anybody else had done this before. And I was starting to wonder, because it took me so many iterations, if this was even possible, because I couldn't get it working, and I couldn't work out why I was having problems. And eventually I did get it working, and I was really victorious. And then I turned it on the next day, and it was just broken. And then I nearly cried. And then I magically got it working again, which is a horrible place in web development when you know that your code has just magically started working again and you don't understand why. It's really uncomfortable. But then I videoed it because I was like, I need proof that this actually works. So I've got a video here of it working on a mobile device. And I just want to point a couple of things out whilst it's running. So you can see the application at the top, which is the server that I've connected to. And then you can see it running on my mobile device underneath. And one of the things that I just want to point out is the latency between the top, which is my desktop machine, is actually pretty quick. It's replicating everything that's happening in pretty much real time. But if you look at the mobile phone, there's actually quite a lot of latency coming in with the hand movement. And the team who've written the Leap networking plugin say that they're aware of the latency, and they also give you a graphing to do your own performance analysis. And they don't know where it's coming from, but they are aware that it's there. So I'm not entirely sure. They were just doing it on two separate screens, so not on a mobile device, on two separate desktop computers. So I'm not sure at the moment if the latency issues I have are to do with the fact that a mobile device is running WebGL more slowly, or if it's because I'm running through Three.Js and that there is a data transfer latency issue across the network from one device to the other. So that's something to be aware of. And I also, just because I know in the world of tech demos things don't go wrong, I was so paranoid that my demo wouldn't work and then also my video wouldn't work that I took a photo. And that's photographic evidence right there. It's paranoia, really. So the last bit that I kind of added in, so I've kind of been doing all of this kind of 3D motion stuff for a while, but the last bit I added in was this kind of virtual reality aspect. So I met with Matthias, who was talking this morning. I met him last year at London.js, and I'd been talking about some of this stuff with his project. And he said, oh, my colleague has written this really brilliant demo you should go and look at, which is entirely to do with kind of doing VR simulation with a mobile phone. So a lot of the work that I'm using is based really heavily on this demo by Rich Tibbett. And like I'm controlling it with my trackpad here, and basically what he's got is a 3D stage in Three.Js, and he's mapped a photo like as a cube around the inside of a 3D environment, and then he's using orientation controls to map around 3 dimensions. And if you're looking at this on a mobile phone, then it uses your accelerometer data instead of a kind of manual control. And when I came back to work on this project, I was like, brilliant, so I know that exists, and I know that will work on my mobile device. I discovered that the team at Three.Js had rolled Rich's demo into their own plugins. So now there is a device orientation control plugin that was written by Wes Langley and Rich Tibbett that does exactly this. So that's the other thing that I'm using for doing my kind of virtual reality when I've got the kind of mobile device plugged into the Google Cardboard. And the last thing that I kind of came across is that when you're using accelerometer data and you're using a mobile phone, you're using quite a cheap sensor, and cheap sensors are really noisy. And somebody else that I've met before, but I also had been talking to at this London JS Conf, was saying what you need is a Kalman filter, and a Kalman filter is a kind of recognized convention in engineering for doing signal processing. And what a Kalman filter does is that it takes the noise in your system and it learns to correct itself over time. So a Kalman filter, theoretically, should get more accurate at correcting out white noise over time. And I struggled to implement a Kalman filter. I found one on GitHub written by a really nice guy who was being really helpful, but because I stopped doing maths 20 years ago, a lot of his help was really going over my head. And my very patient, clever scientist brother also spent like quite a few hours coaching me through matrix transformations to try and understand how to do this Kalman filter. And I still haven't got it working. So in the end, I kind of went back to the drawing board, and what I've implemented is something called a low-pass filter. And that's kind of like a poor man's version of a Kalman filter. So a low-pass essentially just averages out the middle between 2 points. So if you've ever done any animation and used tweening, that's quite a similar technique where it just kind of, it smooths the edges of your signal by taking out the peaks and troughs and kind of averaging out values. But it's not very clever, so it can't correct like a Kalman filter does. And it also, like the problem with processing your signal is that if you smooth out peaks and troughs, you're also, you can introduce latency into movement because you're taking away variation. So if something moves suddenly and your system isn't clever enough to understand that sudden movements are just as likely as gentle movements, then, you know, a low-pass filter can introduce latency into your movement. And that's also a problem for the project I'm working on because we want to have really realistic kind of low latency mimicking of a hand. So that's a problem that I have with the kind of filtering at the moment. So the last demo that I've got is, unfortunately, because this is a VR device and this is quite like an individual experience, only one person can look at this at a time. So what I've got is a video of the actual kind of application working on a mobile device. But if you want to come and have a look at it in 3D, then I'm going to set it up in the break, and you can just come up and play with it. And I would really recommend doing it because it's a really powerful effect when you can actually see the stereo view in 3D in your own eyes. Then this tiny £6 thing is actually really effective. So I've just got a kind of like a really basic 3D scene, and I've got two objects kind of sitting in a grid. You probably can't see the grid because the contrast isn't great on this screen. So like you can see when the mobile device is using that those things are floating in space. So they're the things that are kind of mapped in a 3D environment. And then I've also got the Leap Hand plugin inside of that 3D environment, so you can interact inside of a 3D world. And like as a kind of like final part of the project, what we really need is a physics engine, which is why I was asking David about Oimo, because the last one I was using was called Physics.js. But to be able to reach out and touch things, you need to have a physical object that two things can collide with each other. So you need to be able to map that with a physics engine. So, yeah, working VR and working kind of Leap data. And I'm really pleased to have got to this point because the culmination of several years of kind of dipping my toe in and out of this, but also like kind of three months of solid development, kind of experimenting with whether or not it's actually possible to get a leap motion to read into data in a browser on a mobile phone, and whether or not that's possible, and whether or not that works. So I didn't really talk very much. I meant to talk about this in an earlier slide. The actual project that I'm working on is a piece of health software, and I can't really go too much into the details of what the condition is because I'm under NDA, but what we would really like to do is get money from the Medical Research Council in the UK to fund clinical trials to help us produce this as an actual product. So the condition that we have at the moment, if you want to get treatment for it, you have to go to a treatment centre, and they have a kind of a piece of technology that costs about 30,000 euros a piece, and you have to go to a treatment centre and you can use it for maybe an hour or so, and then you have to go again. But if we can replicate that as web technology for, the cost of a laptop and a mobile device and a Google Cardboard and a Leap, that's maybe a couple of £100 per patient rather than 30,000 euros. And what's more, we can put it into people's homes. So we can increase the number of people who have access to it, but we can also increase the amount of access that somebody has to the treatment. And the more somebody uses the treatment, the more effective that's likely to be, and the more, the more likely they are to receive a cure for doing that. And I hold this project really dear to my heart because it's quite rare as a web developer that you get to work on something that is genuinely adding something of benefit to the world. So I think this technology is really exciting because it opens up a whole load of possibilities in the healthcare industry about kind of like improving rehabilitation for people and allowing people to do it. And I've spoken to doctors who also use a Connect in their work, and they've said that because people enjoy using the technology, they're more likely to do their treatment as well. And that's like another really kind of strong factor in increasing people's likelihood to recover, because if they actually want to treat themselves and, it's a fun game that everyone can join in, then that's a really valuable thing to kind of bring into people's homes. And as web developers, we are uniquely placed to be able to create this kind of software for people. So, I feel really lucky to have been able to kind of start down this project. So I have a meeting with the team from the Medical Research Council next week or in a couple of weeks. I'm really hoping to have a positive result out of that. So the next steps for our project are, I really need to get the Kalman filter working because that's a really essential part of authentic movement and filtering out accelerometer noise. I also want to do some performance profiling on where the latency is coming in on the Leap networking plugin, and they've been really quick to respond to GitHub issues, and they're obviously really keen to have other people working with their technologies. They're really quick to respond, so I'm hoping that they're going to be able to help me get to the bottom of any issues that I might be having on using a mobile screen. I have kind of issues with the mobile that I mentioned, so you've got your processing power and the battery. So the alternative to using the Google Cardboard is that you can do it with an Oculus Rift, and they're not exactly like-for-like technologies because the Oculus Rift is another device that's plugging into your USB port. So it takes out a whole layer of that kind of like WebRTC stuff that you don't need to be doing because you've got two devices that are connected to the same computer by your hardware rather than over a web network. But it also means that you need to be using the web VR APIs, and like it's quite a different technology stack if you want to do this kind of work in an Oculus device or like any other. There's a lot of clones coming out, or in a Google Cardboard, and I'm kind of drawn to the Cardboard just because it's a really low-cost device, and that really appeals to me. And like in the same way that using JavaScript really appeals to me, it's basically free and anyone can do it, and I really like that. And I also saw Mr. Doob retweeting an article about how to build your own kit, so explaining how to create your own lenses and your own headset and how to distance things and how to do the maths for all of that. So if you wanted to put in a different screen that wasn't a mobile device, like an iPad, for instance, or something else, and you can actually hack around building your own viewers as well, which I think is really exciting. And obviously Oculus don't necessarily want to help you do that because that's their USP. So, I'd like to see the cardboard working before I went down any other routes. And that is kind of all I've got for now. You can reach me here. I talk a lot on Twitter because I get bored working on my own. I've got all of my stuff up on GitHub, and the slides are here. It's just cut off at the end, but it's my website and then /WebRebels. So if you want to have a look at the slides, then feel free. Thanks.
Wow, thank you. Do you want to come join me? So I love the way that you start out just really light-hearted and easy, and your font is kind of quirky as well, and then you bam, go straight into Euler angles versus Tate Bryan angles and Kalman filters, and I'm like, oh, maths.
That's right at the limit of my knowledge, so I'm not like a mathematical genius. I had help from several friends who are to explain a lot of that really basic stuff to me, and that helps, but yeah.
Have you found any sort of good resources to getting started with sort of 3D maths for noobs like me? Because I also stopped doing maths about the same.
Yeah, people have recommended stuff. I don't know the name of it off the top of my head. I've actually kind of got stuck into the Khan Academy in the hope that I could relearn trigonometry and a lot of the things that I would like to go back to and relearn some of this matrix transformation stuff. But I love Khan Academy, but the UI is terrible. The iPad's UI is terrible. So, but yeah, I think just learning basic maths is helpful. And there are a few people who have written kind of blogs with kind of animations of signal processing, and a lot of that kind of, there's a lot of kind of wave mathematics in 3D rotations and stuff, like getting your head around all of that is really helpful. But the Three.Js documentation is really clear, and it abstracts so much of that away. Like C's was saying, if you have an abstraction that makes it really clear and obvious, you don't always necessarily need to understand things, but... the Kalman filter definitely tripped me up.
No, I think it's super important to have those abstractions.
Yeah.
So your slideshow, the way you control it with your leap motion, is that something that you rolled yourself?
Yeah, it's just JavaScript. So the interaction box lets you map, if your hand is over here, that you're on this part of the screen. So I'm using a bit of canvas that shows the kind of where the dot of the hand is, and just a little bit of kind of really basic canvas animation. And then I've got a JavaScript counter, so if I hand it over a certain spot, it counts to 10, and then it moves the slide. JavaScript.
Gotta love it.
It's amazing. You gotta love JavaScript. You can do all these cool things with it.
So one of the things that really triggered me what you're talking about is when you start talking about what you're actually using this for. And I know you said you're under NDA and you can't give us more details about the project. But part of what's interesting there is kind of this low-cost healthcare, where you take healthcare sort of away from the really normally expensive, big medical equipment and sort of go, what can we do with a piece of cardboard?
Yeah.
You got some more thoughts around that?
Yeah, I feel really passionate about it. I think it's really important because it's about increasing accessibility to people's treatment and helping people, theoretically all across the world, to gain access to something that they might not have had before, like people on lower incomes. And the things that we're trying to treat would really increase the quality of someone's life. And so that's a really valuable project to be working on if you can use really low-cost web technologies devices that and I think also if you were doing this in a clinical situation, the cost of per unit would come down. If the NHS, or I don't know what you have in Norway, but your National Health, if they can prescribe something that's like a couple of £100 per patient, that could save them millions, and there is money to be spent from the UK government's technology strategy board, and I'm sure in Norway, about reducing the cost of treatment, because that's their main motive as well, is about getting more treatment to more people. And so any technology that you can use to improve the cost of things is a really valuable project to be on. So I feel really strongly about that as web developers. We're privileged to be able to write that kind of software, so we should take those opportunities.
Definitely. I think that's really interesting. I think at the end as well, you sort of briefly mentioned the virtual reality APIs that are coming out. Have you looked at them yet?
I haven't. I have an Oculus Rift, and it's been sitting on my shelf gathering dust for months, mostly because I've been concentrating so hard on trying to write this piece. And I saw someone else demoing it. So there are VR APIs, and they do things quite similar to the Leap, where it detects where your device is plugged in, and it also, like, rather than using a plug-in to do the stereo screen, it creates a lens projection. So the Oculus has a kind of like a curved fisheye lens in each one, like David was showing it earlier, like that kind of curved fisheye. So you can do that in a web browser, and the web APIs, the VR APIs do all of that for you. So theoretically it simplifies a lot of the technology stack that I'm using, but the device cost goes up. And there are clone devices as well. So the Oculus got to market first, but there were lots of other people releasing their own technologies. And Microsoft also have a lot of really interesting products. So, you know, they were the first with the Kinect device, and they've also got their own augmented reality stuff as well. So, like, I think it's really early days for this technology. There is a whole slew of it coming out, like different motion inputs and different visual outputs that are all about 3D space. So I think there is a lot to come in and having it in the web is exciting to me, because if you can do it with JavaScript, then yay, JavaScript, you know.
Yeah, I think so too, and I think it's going to be really interesting to watch that space. And I really hope that you get funding and for your project and can move on with that.
Yeah, I
it
hope
looks
so too.
really fun. Thank you.
Okay,
Thank you for coming.
Thank you.